uh, subject name compiler design. In this subject, we discussed some of the topics previously, that is related to syntax trees and then directed translation, syntax director. Now, today we are going to discuss about the syntax directed translation for the given grammar. Syntax directed translation schemes. And the outcome is what is the syntax directed translation, demonstration, and explanation about this. Now let us go to the quickly the topic one by one. Now here, what is meant by a syntax directed definition? That is here the simply it is nothing but a grammar association of some rules. That means the information that is described apart from variables and terminals in the given grammar, these notations are called as informal notations, and these notations are called as semantic rules. So we know that a given grammar contains set of rules. Now for this we are going to add a special uh, notation, that is a description of the some of the notation, that is called informal notations, and these notations are to called as semantic rules, and these notations are called. So the combination of the rules as well as the rule, that is set of rules and semantic actions, that is to be described in case of that is called together it is called as syntax directed translation. Syntax directed translation. Here every non-terminal is going to get one or more than attribute, or sometimes it is a zero attributes also. There will be no attribute depending on the type of the attribute. Depending on the type of the attribute. Now in syntax directed translation, a attribute is of type, that is which depends what type of attribute, that is a notation to be described, and the values of these attributes, here values are to be described. That attribute associations are to call as semantic rules association. Semantic rules associations. So in this way, a syntax directed translation is to be specified. We will see, let us see with an example of notation also. But here the main concept is the attribute notation is described as a value representation, and this attribute hold some value, maybe either a number, that is integer number, or a character or string format, or object reference, or any etc. So these going to be described for this association of attribute values for the given context of the grammar. So let us see how this can be represented in the form of a grammar association with this. So let us see an example. Here the given grammar contains, see here, E derives E plus T, and A derives T is the second, and third one is T derives T star F, and another one is T derives F, and finally what? F derives NUF. Now in this we are going to write all these one as productions. Left hand side we are going to write all these. So these are called as production. So we have written E derives E plus T, second rule, third rule, T derives F, F derives. Now we are going to write a part of semantic rule. So previously we have noted down, see attribute associated, the semantic rule must be what? The attribute associated value for each of the production variables. Each of the production variables, we are going to write this attribute. About attribute association, you have to represent some value notation. That value may be, that is the corresponding rule, it may be for particular variable, it may be integer or string reference or any other object reference. So that is to be considerations for each of the value. So for example, here we have considered the first production e derives e plus t. For this, we are going to represent a notation, that is what is the of type e. So we are going to write a val. This is to be considered as the attribute association of this particular variable e. So that's why it is the representative. Now this attribute association and this val, the dot val, together represent the semantic rule of that particular variable. Now we have to write for each rule, then we can consider it as a semantic rule of that particular production. Now we have to write the E also second. First you have written first E, and then we are going to write the capital E dot val plus what is the attribute association for this one. So that is represented, also can be represented by T dot val. Now the corresponding production is completed by appending the curly braces, both left and that is to be, the production is to be enclosed with the curly braces. So left hand and right hand. So for this it is to be completed with this. Now we have to write the second one also. So for second one, what is the attribute association value? E dot val, that is left hand side, and right hand side what it contains? T. So that is to be written as T dot val. Now it is also completed. So say production rule 1 is completed by inserting that attribute association within a curly brace for each of the variable, then we can say it is semantic rule is completed. So it is nothing but a attribute association with that grammar association of this rule. In the previous we discussed about the definition. Now comes to the third, that is T star F. T derives T star F. The association is T dot val for left hand side, and right hand side is T dot val, and we have to keep the star operator as it is, F dot val and the left hand close curly brackets. And then the another derivation, that is here rule is T derives F, attribute association is T dot val, and this one F dot val, the completion of the semantic rule. And we are going to write the semantic rule for the last derivation, that is F derives num F dot val and num dot lex dot val. That is also come. So like that we have to write the production rule 1 and rule 2 for semantic rule, rule 3 for semantic rule, and rule 4 for semantic rule, and rule 5 also semantic rule with the corresponding attribute associations. So here the val represents the numerical val, lexical val. This is to be used for the construction of parse tree and also syntax tree in order to compute each and every attribute associated values by visiting each tree node, and then compute the notations, summarize the values from left to right and get the final result. It is to be very useful. In that process, it is to be declared as each and every attribute, that a variable notation as the attribute associations, and finding out the semantic rules to further construction of this parse tree. So this is a very helpful mechanism to go further phase and levels of the computation of the compiling process, where what is the value of that particular variable holds, and that branch of tree it can be computed, and then it leads to the second process. So let us see how this computations takes place for this construction of parse tree or syntax tree in order to compute these values of each of the derivations. Now let us see the computation how it will. For example, if this is the given grammar, this is the example. In this first one is E derives E plus T, and E derives capital T, T derives T star F, and T derives F, and finally F derives NUM. So this is the part of the given derivations in this given example. Now we have to construct the parse tree of this S equal to 2 plus 3 star 4 by implementing the given productions with these rules. So in order to draw this computation, we can do the attribute association values, and then we are going to compute each and every tree what is the value of this particular attribute association. Later we will see. First we will concentrate on parse tree, then we will see the how the translation of the each and every attribute value which is to be taken care of each branch of the node in that particular tree. We will see that one. See here, in order to derive 2 plus 3 star 4, the computation 2 plus these are given parse tree notation for this tree. See here, what is the computation of the choice here, plus operation and the star operation to be considered. So in order to consider these two cases, that is plus and so you verify the suitability of the productions which are mapped to for this one. So here E derives E plus T, which is to be because the plus operation is available at the beginning. Maybe it is available to the remaining also, but initially for this construction starting, we have to consider whether which one is the majorly applicable for this to draw. And another one is star operation is required. So we can use either of this one. So that's why here if you consider T star F, then if you consider T derives T star F, now you may get the choice whether the T contains plus operation or not. So that's why here the T contains only T star F, again multiplication will come T derives F. So that is the only choice. So again multiplication is not required, we required a plus operation. So but here plus star is available. So left hand side we required a plus operation, but T doesn't contain plus operation. So instead of that one, can we verify the E derives E plus T? Can we go to this one? So here E derives E plus T. So here the plus is covered, and the remaining for T any possibility of getting star up. Yes, here the rule is available, T derives T star F. This covers the notation. So that's why we are considering this E derives E plus T as a first one. The first production of the branch of the nodes, tree nodes. So E derives E plus T. So for this E derives E plus T. So root node is E. What are the left plus E, and subnode next child node next child node. In this way we are going to write this portion. In this way we are going to. After completion of this first step, second step is what is E derives next. Any other options which are to be available in this. So E derives E plus T. Next T derives T star F. T derives T star F. T derives F. Now out of this, we are going to see the consideration of E, which contains the attribute association. So we have to possible case are two things. One is E derives E plus T. Second one is E derives T. Now in this the considerations plus is operation is all not required. Why? Because the string doesn't contain plus operation. Furthermore, only one time it appears. So that's why we can take the consideration of E derives T. So that's why E derives T only. Next, T derives any other option. Here the star and star F and two more cases are there, but this one is considered because star is not required. That's why T derives F. Now F derives only one derivation, so that's why you can write a number. So that completes the left branch of this particular tree structure. Whereas then if it comes to the right side t, so here we are getting the two options for the derivation t. So either t star f, af. Why? Because here in the string we required a star notation. So that's why we will consider this t star f. T derives t star f. Come to the leftmost branch of tree. For this case, capital T, which will contains again further two protection, that is T star F and F. But for the given string notation, star is not required, so that's why we will go for second one, that is T derives F. Again, F derives, there is only one set of protection, so we will consider F derives N here. Star we can kept as it is. Why? Because there is no further sub-productions of this related to, only variables are to be available to expand. Now next comes to the F. So in this branch, F contains also only one set of rule, that is number. So we can directly go through this one number. So if you see all the leaf nodes, here left hand side num, here also the branch num, and here also num. So we will get the each of the production values with the num notations. So what is num here? The corresponding 2 plus 3 star 4. So here 2 is the number for this branch, and for this 3 is the number, and for this it is 4. Now 2 plus 3 star 4 for this branch will get 2, and from this plus, and from this branch it will be 3, so that is to be, and for this branch it is star, and for this last leaf that is 4. So in this way we are going to construct the parse tree for this each of the given set of productions, and which leads to the construction of this string notation for the parse tree string notation 2 plus 3 star 4. Now, how the attribute association values can be calculated with this production? Say for example, this same example, how the attribute, we see that here the values are to be described. Now, how the summing up of all the values for this corresponding string 2 plus 3 star 4 has been taken place while construction of this parse tree. See here, now the 2 is the number. For this is to be upwards to this particular f. What f contains here? F dot val. This is called as attribute association rule. That is, previously we have completed semantic rule associations. So the given grammar plus the attribute association values, that is called as semantic rule, which gives the syntax directed translation. So that's in this way the value number is to be given, that is f dot value equal to 2. Now if you go to the upper level, now this will be given to this t. So what is t here? T dot val. Now is equivalent to f dot val, which is equal to 2. Which is equal to 2. T dot val, and why? Because the lower level contains a number value that is to be considered with the f, and again f is to be considered with the corresponding t value. Now any other is there uppermost? Yes, uppermost one more is, so e. What is e dot val? So this is also equal to 2. E dot val equal to, so that is given as e dot val equal to 2. Now this is the entire branch. Here you will get the value is 2. Now e dot val is equal to e dot, in the previous you have seen, e dot val will get plus, here plus operation, and then the left branch t. So what is t here? Now 3 will get here f dot val. Now this how much value it is getting? 3. Now the f dot value equal to t dot val. Now t dot value is how much? The attribute association value here 3. Now this 3 is given, is passed to the upper level, that is 3. So now you will get t dot val equal to 3. T dot val equal to 3. Now the star operation as this, and then that is to be carried out with the corresponding, what is here in this branch? F. What is F dot val? Here 4 is available. Now this 4 is passed to the attribute association of this variable F. So F dot value equal to 4. Now this 4 is to be this 3 and this 4 both are to be computed. Now here T dot value equal to how much? Here F dot, now this T dot value equal to this T dot val plus F dot val star. Now star, this T dot value equal to 3 star. What is F dot here? F is F dot value. F dot value is 4. Now 3 star 4 will get value is 12. 3 star 1 value is 12. Now in this computation, E dot val is equal to the final E dot value equal to E dot val left hand side plus operation this one and T, that is T dot val. Now what is E dot val in the left hand side? 2 cap number 2 and here plus operation and right branch of the tree contains capital T. What is the capital T? We have computed capital T value dot value is 12. So I have to write that 12. Now 2 plus 12, what is how much? The value computation, that is 14. So this computation value 14 is the result of the final root node of this E dot val. Final result E dot value equal to 14. So in this way we are going to compute attribute association of each of the values for the given parse tree. So all the values we have given an arrow mark to be represented with the attribute association for each branch of the node tree or the corresponding node, and it computes the calculation and moves the result to further up level, and from left to right it calculates, and finally the root node computation takes place and gives the result as 2 plus 3 star 4, that is 2 plus 12 14, which gives the result of this. Now in this example, what is the expression, that is the parse tree after construction of the parse tree we have evaluation with the like previous example attribute associations, the corresponding here the different it is given as 3 plus 4 star 5 plus 6. That means we have to compute this particular expression. We have to compute this one. First you have to write the parse tree construction. Before that we have to write a semantic rules. Before that we have to write a semantic rules for this production. So here a set of different productions are given, but here the attribute associations are very simple. Why? Because previous examples are also we have calculated like this. So it is like the particular dot value association of each of the variable. So for example here if you see here L dot val equal to E dot val. Similarly the second, third, fourth, like this we have to compute each and every. Simply we are going to write this particular value. Now here if you see E dot val equal to T dot val, E dot val plus T dot val, third, fourth one, T dot value equal to F dot 1. So this we described in the previous example. Now coming to the parse tree notation, while we already told that while construction you have to verify this step. So that's why the grammar associated rule. For example here the here it is given productions. These to be considered for evaluation of this one. So I may apply what is the notation for this. So 3 plus 4 star 5 plus 6 which contains the operation plus star plus. Now you can go for either this production as a root node considerations or this one. Why? Because it contains the operator which is actually required for the parse tree construction. Where if it is not required, then we have to evaluate a different process which needs to be further evaluation low levels in the summing up. So first we take L as the root node, and for the which gives an expression. So L derives E, which gives the expression. The expression may contain T also. That T may be derived either T star F like this. So here L is to be considered as for the first root node. L derives E, E derives T. L derives E, E derives T. So this T may contain two rules. We can consider either this one or this one. So here we will consider T star F. So that's why I have taken capital T star F. Why? Because it leads to the further derivation of the corresponding string. That's why we have to consider this one. And the second one is to be used for later part. Yes, if you consider this as a first one, but we cannot further with this capital E. So that's why capital E may also contain expression, the expression E plus T, but we may not get the star operation. So we may suspend, we may not get that operator. So that's why instead of getting this using, we are going to use this as a hierarchy of the tree structure. And furthermore, either T can be evaluated to once again F or T star F. So that way we write TF we can write. Once again F contains expression. Here also F contains expression. So the expression is E plus T once again. So that's why T derives F. Here also F derives expression. So this F which contains expression. E here E contains E plus T. So we are getting the part 1 and the right side also we will get the part 2. So that's why here E plus T part 1 and we are also getting one more part E plus T as the right hand side part. So that's evaluates the computation of E derives. Once again we have one more option, E derives T. So that's why I have given E derives T we have considered. Once again T derives F. F is a lexical value. Yeah, attribute associated value. F is a number. The previous, so F is digit. So what is digit here? The number is 3. That one we are considering this as 3, and this branch is completed. Plus operation in the corresponding T value. Once again T derives F. F derives digit 4. So keep it star as it is. There is no further low levels of this one. Again comes to this branch of the tree node structure. Here E derives T, T derives F, F derives number. What is number here? We have considered as 5. From this for this example, 3 plus 4 star 5 plus 6. So that's why here we have considered. Previously left branch we have considered 3 and 4. Now after star operation we have given consider 5. Now plus, this is to be considered with the plus, and last leaf node with the T derives F, F derives digit, and here lexical value is 6. So F derives number. So that is to be used for the two cases, all the cases for identifier, and this lexical value. Now we are going to sum up each of the values for each branch attribute association. So here F dot value will get equal to T dot val, here E dot val. Here also F dot val, again T dot val. Now E dot val plus T dot val. So what is E dot val? 3. And what is T dot val here? 4. 3 plus 4, that is 7. So that's why you will get value 7. Value 7 here at the left branch. And this side if you consider F dot val which is equal to T dot val which is equal to E dot val. Now E dot val plus here F dot val equal to T dot val. What is T dot val? T dot value is 6. Here F dot value is, E dot value is 5. So 5 plus 6, 11. Now left branch here T dot val equal to 7 and right side branch F dot val equal to 11. Now after performing these two with the T, that is T dot val equal to T dot val plus F dot val. Now what is the T dot val value here? 7. 7 plus what is F dot val? 11. Now 7 plus star, here it is the operation is star operation. So 7 star 11. So 77. So 77 is passed to the E dot val. Now E dot val equal to 77. Now expression is here they given L dot val equal to E dot val. Now what is E dot val? 77. Now L dot val equal to 77. So finally what is the result of the expression? L dot value is 77 for the given expression. So in this way we need to draw the parse tree construction structure for the given string 3 plus 4 star 5 plus 6, and then we have to implement the attribute association rules for each of the attribute, and then find out the lexical value of that each of the branch tree. After noting down branch of the node, compute the subtree node structure for each of the branches of the corresponding tree, and we will move to the further levels up, and finally we will get the corresponding value L dot val, which is the root node, that is here in this case. We have started with a node structure L dot E, that is L dot val equal to E dot val. Now this is to be computed, and what do we get? 77. So L value 77. So which describes, that is the given example string notation. That is syntax directed definition with the synthesized attribute value. So attribute value associated is this for each of the variable L dot val, E dot val, and then parse tree construction we have constructed this one. This is the parse tree structure, that is, and we have combined. Previous example we have separated both the parse tree as well as the attribute association rules. Now in this example we have not done separate two diagrams. Previous example, see here, this is the parse tree construction and attribute associated values f dot val is separately written, but in this example we have combined these two notations, parse tree and attribute association, and get the result of L dot val as the root node structure. So we can write separately, or we can combine, and later we can conclude that the result of the expression final calculation as the string notation structure, that is, so for construction of the parse tree. This expression 3 plus 4 star 5 plus 3, draw the structure notation, parse tree structure notation, verify the attribute value address associations, and then calculate this each of the attribute value for separate branch wise and get the result of the expression. So in this way, that is the syntax directed definitions of the attribute associations, and then semantic rules are to be applied for the given grammar notation. So it is very easy to first initially start with semantic rules. Just make the definition clearly. We are not going to do anything. We are going to add an additional information that is called as a separate notation. These notations are called as semantic rules. Once you add these semantic rules as the attribute associations with the curly brackets, then we can proceed to the corresponding notation. So this addition of the semantic rules for the previously are not added this one in the previous structure, but in this we are going to add and then get the smoothness of the functionality of the parse tree structure. So this is called as syntax directed translation scheme of the for the construction of parse tree. With this example, we can conclude that it is very clear to easily identify the expression evaluation and the construction of this syntax tree or parse tree notations. So next coming session we are going to give a brief overview and discussions about further topic, that is how the syntax directed translation schemes can be applied for the statements, and also three address code notation. What is the three address code notation and how it can be implemented with the different types of the statements like boolean and the expressions and flow of control statements, etc. So for this these contents which are available in the textbook, that is compilers, principles and techniques, that is three others book, Alfred, Sethi and Goodman. As the time process, then today we are going to stop the session. Next coming class we will come up with a new topic. Thank you once again, all of you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.